This is Euclid Book 3, proposition number 9, and what Euclid does in this proof is he takes Euclid Book 3, proposition number 1, one step further. First of all, he has you draw a circle, and the circle will be A, B, C. One giant circle passes through A, passes through B, passes through a whole bunch of other points, also passes through C, and comes right back to A. Alright, then he says, I want you to take a point in that circle, right here. And we're going to call it D. And he's going to prove that this point is the center of the circle. Now, how does he do this? Well, he draws a line from D to A, D to B, and D to C. Alright, the first thing you should know is that all radii of a circle are equal, so we now know that line DA and DB and DC are all equal in size. That we know. Alright, now, Euclid wants you to bisect line AB. He wants you to connect AB, which this is BA right here, AB. And once you connect AB, then you are to use Euclid Book 1, proposition number 10, and bisect AB and get a point called E. Furthermore, Euclid wants you to draw a line from point B to point C. And when you do, you're to bisect BC using Euclid Book 1, proposition number 10, and come up with point F. And then Euclid wants you to draw a line from point D through point F all the way up to L and all the way back down here to letter H. Alrighty then. Now Euclid will also have you draw a line, eventually, that will stretch from point D to point E, all the way over to point K, and all the way back over here to point G. Alright, now, Euclid says line AE is equal to line EB. Well, here's AE, here's EB. And we know this because this great big line that starts at K, goes all the way through E, goes all the way through D, and all the way back over to G. This giant line bisects AB, thus making AE equal to EB. Like that. Now we already established that ED equals ED. So this one right here equals itself. And then we also established that because we have all radii of the circle are equal, then line AD, which is this one right here from A to D, and line BD, which is from here to here, are equal in size. And because of this, angle AED, which is AED, is equal in size to BED, BED. So these two angles are equal in size. And if they're equal in size, then they are also 90-degree angles. Well, to prove they're equal in size, you have to go to Euclid Book 1, proposition number 8. To prove that they are also 90 degrees apiece, you have to use Euclid Book 1, definition number 10. Now, because of all of this, and because of Euclid Book 3, proposition number 1, we can also say that the center of the circle is going to be located somewhere on the line of GK. Well, here's line GK. G goes through here, goes through point D, point E, and all the way over to K. So somewhere on GK is the center of the circle. But Euclid's not finished yet. He uses similar reasoning to also prove that the center of the circle is on line HL. Well, where's HL? H starts here, goes through point D, goes through point F, and comes all the way over to L. Just like that. Now, there is only one point that line HL and GK share, and that's point D. And since point D is shared with GK and HL, then it becomes the center of the circle, and that's what Euclid wanted to prove in the first place, and we're done. Alright, I will tell you more in a future video, so stay tuned.